do not believe that a structure like this has ever been built before.
What holds this building up in place?
It's high quality, over-the-top engineering.
I had a lot of sleepless nights.
It was nerve-wracking, hearing the beams ping, pop, bang, feel the building sway a little.
Everything was different on this job. Everything was difficult.
We know what's going on. There's the one that moved.
For a lot of people in this project, this may be a one-time deal.
I mean, it's big,
Mega, tough,
unbelievable.
They will not forget this building and being a part of it.
We've created a remarkable experience for people of Salt Lake.
111 South Main is actually meant to be a very simple Class A office building.
And one of their key pieces of criteria was they needed to build a theater that would seat 2,500 people in order to attract the kind of Broadway-style plays that they were after. One of our pieces of key criteria was to build a floor plate that was 20,000 square feet. The city came back to us and said, you know, we've done some initial planning and design and found that we can't get 2,500 seats on the piece of ground that we have. We need another 5,000 feet, which would have reduced our pad down to 15,000 feet. So we were at a little bit of an impasse for a while.
111's rise to becoming a skyline marvel began at this impasse. Both the city and 111's owners needed the same space to meet their goals. Given that 111 could not have any load-bearing columns going through the theater space below, a solution over how to utilize this shared space needed to be found.
After being frustrated with whether columns would enter and pass through the UPAC or whether our building would have a seismic joint in their building, which would be very disruptive, we came up with a sketch one Friday afternoon on a go-to meeting that showed a cantilever truss system where we suspended the columns from the roof of the office building. And there was just a huge sigh of relief in the room.
We were sitting in a meeting and he actually said, you know, we could hang the building. And we all kind of looked at him like, we could do what? And oh, by the way, it sounds expensive.
And after that, it's just been 2.5 years of just go, go, go.
There's been a lot of theory about how these two buildings could have come up at the same time, perhaps one before the other. The fact of the matter is, we did both of these projects at the appropriate time, which was at the same time.
Some wonder kind of why didn't you take the columns all the way down on the north and simply hang the south? When the structural engineers used their software to model it in an earthquake event, that side of the building, the north side, was absolutely too stiff. By taking the columns out and creating this balanced teeter-totter effect on the hat-truss, it performed much, much better in a seismic event. Now, that opened the door to much more exciting things.
A scary one, a scary door was open. I think to our board's great credit, they saw the benefit of going all in. Now, it was a bet at the time because we didn't know how much upward pressure we were going to be able to put on lease rates.
It was no longer a merchant-grade building. It was going to be a one-of-a-kind, iconic building for the market. Now the finishes needed to follow through. So, you know, working with Oakland, over time we were able to develop a system
and turn it into something so unique, certainly for Salt Lake City, if not for the Western U.S., that it begins to grow a name for itself.
We're coming up on 100 years as Oakland Construction Company. As my grandfather and my great-grandfather were building the company and work was tough to come by, they built their reputation by being successful on projects that others just didn't want to do.
There are several categories of talent and skill set that a developer is looking for in a GC, and especially in a building like this. Oakland was uniquely qualified to handle a structure of this complexity.
The roots of Oakland's passion to construct complex buildings reaches back nearly a century ago to more humble beginnings when Norwegian-born John Oakland applied his knowledge of carpentry and shipbuilding to lay the foundation for a construction company in Salt Lake City, Utah. A unique opportunity came for Oakland when his company performed multiple renovations on Utah's famed beehive and lion houses for the Church of Jesus Christ of Latter-day Saints. Decades later, and just around the corner, the Oakland Construction Company was now at work on another iconic project for that same client, City Creek Reserve, a real estate arm of the LDS Church. Since 1918, Oakland has emerged as a leading construction company of skilled builders and craftsmen that have left an indelible mark on buildings throughout North America, having proven themselves time and again to grapple with means and methods, technologies, and time demands. Oakland was called upon to come to downtown Salt Lake City to 111 South Main Street and embark on a building project never before seen or imagined.
We are a family company, but the line between Oakland family blood and Oakland employees is faded. We're all going to fail together. We're all going to succeed together. Our field people take on a very humble and collaborative approach, and that leads to success. There's no ego at Oakland Construction.
The footprint of this building is only about 1/3 of an acre. And so you're really looking at a residential lot at that point. The soil types here in downtown Salt Lake, I mean, it's former Lake Bonneville. We have to make sure that this soil has the capacity to bear up the building and not move in the event of an earthquake. Where that led the design team was H-piles. And what that does is that compresses the soil and develops a friction against the steel. The technology of driving these piles has not advanced very much in the last 150 years, by the way. It took us several months of very loud, obnoxious, and I apologize to all the neighbors in downtown. It was a very difficult process to get through.
The footing on this project was very unique. We had some areas of this footing that were 19 foot thick. We had issues with the curing of the concrete. It was getting too warm in the center.
They have found on demolitions 50 years down the road that a lot of the interior of those mass pours is breaking down.
In contending with that heat, we have to implement something, again, that's never been done in this market, which was to implement a thermal control plan.
We brought in a very large water truck, pretty much took up half of our site down there.
We ended up pumping about 19 million gallons of water through a closed loop system so that there was no question mark associated with this building. The structural integrity of this building is unquestioned in terms of the concrete, and that's what was critical to us.
It was a significant cost to the project, but we felt as Oakland that being one of our core values is important to do it right.
I'm the most obnoxious person on this corner. Gets me in trouble a lot with public, you know, and it's all in the name of safety. Can't be politically correct when you're trying to keep people safe.
It is probably by far the smallest site that I've had to work on downtown.
All the material, all the equipment was brought in off that 16-foot gate onto our road down there. We did more with less, more or less, you know.
The perfect storm of building this building occurred pretty much from the beginning in pre-construction. From when we was asked, you know, can we build a building backwards from the top down to build a building from the bottom up that eventually hangs off from the top. You know, and then we get a scenario thrown at us. Oh, by the way, we got a cantilever over an existing building. There's never been a building built like this before, ever.
It scared me a little bit because it's made the building very unconventional in its construction process.
Going forward, we would have to have Oakland build 100% of the concrete core, go to the roof, build the hat truss, and then build the rest of the structure. What that does is it basically stops work. All of the other trades can't complete any of their scope because we're not done.
SOM came up with the idea of a saddle cable system of having a temporary saddle where the building could be built conventionally.
Basically, the entire center of the structure, all concrete, able to run cables through there in order to hold up the south side. Bridges could be built this way, but not buildings.
A lot of concrete went into this. We were able to use a Perry self-climbing system on the formwork. We were able to cycle a floor every 5 to 6 days.
You had to make sure that each floor or each 2 floors you put on there and poured the concrete, that you kept the building in a balance. If the building become unbalanced at any time, obviously you know the outcome.
Every time we would add a deck or a level of curtain wall, we needed to know how the building was responding to that, so we could make adjustments accordingly so things were not getting out of sync.
You do have the perimeter steel that will stretch 1/8 of an inch per floor. Core crush is as you add on to the weight of the concrete. So the engineers had to come up with a calculated theoretical elevation that included all of the core crush, all of the camber, and all of the steel elongation, and come out perfect.
I'm most proud of actually getting the core up on time and on schedule. It's hard to believe that all the load does transfer through that core, because you think about it, there's a footing, a mass of concrete running vertical in the air, and on top of that there's 6 articulating bearings, let's call them, that all the structural steel hat truss is resting on.
So we had to get these mock-ups right the first time. We had to verify that nearly 100% contact surface between the grout and the steel surface of the bearing.
We sheared off an edge, and we noticed that it was aerated. There were air bubbles inside the grout.
And we're sitting at a month, and we're thinking, what are we gonna do? Let's test it again. We tested it again, even worse results. We did more and more mock-ups. Finally, we found a product that would almost create a glass surface.
That process was what we call a zero tolerance for failure. It has to be perfect.
When we got up to building the hat truss, the difficulty is that every one of them joints we had assembly anywhere from average of 20,000 pounds to 44,000 pounds.
We had 90 days to get this hat truss done. With the amount of welding that we had in the hat truss and how many picks we had, and it was through one of the coldest times of the year.
You had big old groove weldings that you had to put together. And one joint would take one man 40 hours to weld one beam end. And you got high winds up there. You got snowstorms going on you.
You know what? You could be working for days on a weld, but if there's an occlusion that we can find, you're stripping that weld out. As these guys stepped on the job, there was a complete buy-in from them. There was, how are we going to do it? But there was never a hesitancy to achieve that 100% goal.
There was a criteria in our specification to limit the wind deflection of the glass to be 1 inch. And the corners deflected and exceeded that to almost up to a 1/2 inch greater than that spec criteria. Now, it doesn't create a problem for the glass strength, but it's the feeling you have in the office space, and the owner wanted to limit that. So we needed to upgrade the glass to 3/8 of an inch glass in the corners. So the owner and architectural team decided to change the entire skin of the building to 3/8 inch glass. They're very heavy, so it was an accommodation we had to deal with. One thing about 3/8 inch glass is it gives you a flat surface, much more than you would with 1/4 inch glass. The aesthetics from the exterior view is something that the owner and the community will appreciate over time.
111 continued to rise above the downtown community, overcoming challenges and exceeding typical standards to achieve the owner's go-all-in approach. The pinnacle moment finally arrived on a cold winter day when the load of the entire building would be transferred from the temporary shoring systems onto the hat truss above. Every weld, anchor, survey, and calculation would be put to the test. For these guys, it was their Super Bowl Sunday.
Okay, so we'll start out with SOM and HACCP's okay to go.
This is a major milestone. As we met this morning with our safety meeting and orientation, I reminded everybody this is our Super Bowl Sunday.
In the event that anything happens that we need to stop, anybody can say stop. There's no hierarchy here. 1 7/8, 0, 1/2, 3/4, 1/4.
What we essentially had to do is lift the building up and attach it to its final attachment point in the hat truss. When it was released, we had to make sure that the right amount of camber would come out of the truss so the floors would end up at the correct elevations.
Through the process of steel erection, we had to continue to push up, and we were stretching those cables.
Several of us have not slept in that 2.5 year period, but we're really, really happy to get to this time.
And now we're basically doing the opposite. We're unstretching, we're jacking down, we're allowing the building to come down. We're taking the load out of the cables, and so we're basically relaxing all of our temporary systems.
I remember the first time in San Francisco, it says this building's going to drop 3 inches. Then he went on. After they went on for 15 minutes and there was a break, I says, can we go back to the idea of this building dropping 3 inches and curtain wall?
And one thing we could not have is glass coming off the building.
The anchors that we have on this building are 3 times the tolerances we had to build into them than normal buildings. And today, you know, as they lower this building, the curtain wall is just say, bring it on.
All right, everybody, we got to go from SOM and Hassett Engineering. We're going to give it over to SME.
It's your show.
Thank you.
Tell me when you're ready to dance.
We're ready.
On 3. 1, 2, 3, jack. There's a wonderful move. I love that. If we don't get that, it's not going to work.
One just came down.
Every time we moved a building less than 1/8 of an inch, that building would talk to you. The building, it's alive, you know. So when we'd hit that button to you, and that thing would just give you the growl, a sound that's unbelievable.
Doing what we think it will.
Say that again?
You guys good to go on your floors?
Yeah, Western's all good. Now I'm on 11 right now. I'm getting a bunch of gapping.
And after the next lift, let's see if they're continuing to grow.
All right, 10-4.
I love that music. We're down to 600 right now. That's half that load. That truss has got some torque in it right now.
Everybody stop.
Yeah, let me know what's going on. In San Francisco, we have a full-scale model. The computer is telling us what happened.
The project engineer, Jorian Baza, he's been involved on the phone the whole time and comparing with our mathematical model.
Jorian's model, he's seeing A come down an 1/8 inch after all the other stuff, all the other ones anyway. A line lags behind an 1/8.
Yeah, okay.
That's exactly what we're seeing.
That's exactly what we're seeing. Jorian, he's a bastard.
Look at this cable right here. 4 inches of cable. I can't even pick that up. That thing is roughly 40 pounds per foot.
Your side's moved a lot.
That's holding up that building. And we stretched that cable 4.5 inches.
2 3/4 again. They're moving good. Okay. Let's just double check these.
It was great to see the window wall, the curtain wall, stand up and do its thing like it was designed to do. I mean, it's awesome.
Level 5, which was our baseline, was just perfect, 0, flat.
Seeing all of that happen like we put it on paper was one of the most amazing things I've ever seen in my career.
It was like, boy, high five. Bam, you know? It was the greatest feeling ever.
Load down. Full trolley. One swing. Load.
The structure was up, and now the pressure was really being applied to our subcontractor pool. Not only was it condensing the schedule almost virtually in half, the owner's desire then to interject all of these TI trades, which really put a lot of stress on our vertical transportation. We went into this with our eyes wide open.
This one first, and then you want this one, or you want the middle?
Once the load transfer occurred, we could then start loading out on the perimeters of the building the electrical systems that needed to be installed. The generators, the backup power, is all located on the very top of the building. Very different than any other project that we built. And we had to figure out a way to get those generators into that hat truss. Our building information modeling group spent hours and hours modeling 3D designs on how this would work. Literally, we had inches.
You know, there's been a lot of players behind the scenes to put this kind of thing together, and it's quite a feat to get them up here and have it right.
And that's really what this equates to, is how do you take that thread through the eye of a needle at just the right time, and making sure that component is in place at the critical moment to allow all the other things to continue to happen.
With the finish line in sight, Oakland led the way as the trades got cranky. SME steelworkers removed 500 tons of temporary steel from inside the structure and spent weeks pulling over 12 tons of steel cable. J&S Mechanical designed high-pressure casings and boosting systems to manage water pressures throughout the building, isolating each vertical piping system from the structure. Cache Valley electricians installed a state-of-the-art fiber optic infrastructure and redundant data feeds. On edge, at 380 feet above downtown, steel encounters glazers, locked-in panels surrounding the hat truss to create a translucent glass veil. These glazers then descended to the ground floor to finish 111's signature glass lobby. To achieve this, the design team developed a customized counterweight system.
Yes, sir. Like I said, let's just look twice, move once. It's all glass around us. Ready? Let's do it. Let's go ahead and suck it to it, huh?
Right there. That's it.
We need to work up a bump. Your weight's where you want them, Tim? Load up, Ghost Rider.
I'm going up.
I know. Tyler, working up as we roll.
Working up, Eric. Trolley out easy. Swing, trolleying in. One baby bump to the left. Inches.
I'm so close, bro. Let's try to get it a little better. Give it one little bump. Hold that. Load. You liking it, my man? We push her in. You ready with your blocks?
Gary, you gotta pull your way.
Working down till we touch pad, baby.
All right, working down easy.
Reaching this touchdown milestone had to first journey through years of planning, mock-ups, transport over high seas, threading the needle of logistics, and hitting the zero mark on the counterweight system every time without fail.
When we get done setting that light of glass, Tim has to control the counterweight and bring it back to zero. Once he hits zero, then we lower the crane until the weight hits that exact dry weight, and we know it's safe to release the glass cups.
In a seismic event, the building itself on the perimeter actually flexes down and upward. So as the building drops down, the rafters actually just pivot and flex with the building. And all you're going to have is a corner that comes together with no physical way that should be there.
That is the edge of 111 building right there. That is our outside edge. You're underneath, basically in the basement of 111. That's not their building. From this column line back is what the tower overhangs. Terry, let's go over to show them what they got going on here. Let's come in out of the sun and shade up underneath the 111 South Main cantilever. Think about where you were on low transfer day. This floor, moving up and down, all 25 levels of steel, concrete, glass, all working together, held up by 6 4-inch structural steel cables. That's what it was all about, this cantilever.
I think the first thing that we had going for us was we had an immense level of trust with this owner.
They were at the table with us during the design of this building. They saw what was coming. I'm sure a couple of times they felt like ducking.
The glue that holds it together, with all due respect, is the team with Oakland Construction.
Over a 2.5-year plus stretch of construction, the ability to deal with problem after problem after problem in an extremely professional way, to not back away, to not point fingers, maintaining a great sense of humor, are great attributes to have in a GC. I mean, we hope we were as good a partners for Oakland in this project as Oakland was for City Creek Reserve.
There's a lot of your heart and soul that went into a project like this. Overnights that you're there sleepless nights to get it done so that the owner gets what they're asking for.
111 Main pushed and stretched us all, but I think we're all better because of that.
What 111 South Main has shown about Utah is the local contractors that worked on this project can now take on world-class projects at any time.
This has pushed me to the limits of where I want to progress every year.
Now what we've done is we've allowed architects to design pretty much whatever they want. The cantilevers just got larger and structures just got a whole lot more unusual.
You know, the thing I'm most proud of is our resource pool, our self-performed work, our carpenters, our laborers, our finishers, our operators, you know, let's work tireless hours.
111 Main was kind of the culmination of all these years of experience and relationship that we have with each other.
So everybody was buying into this thing and everybody did their part above and beyond. As a team, that's contagious.
When you drive by and you say, we did that, it becomes a little bit more of a life, and it brings the city to life, and it brings us as people to life.
Rising above the heart of downtown, 111 fulfills the vision of city leaders and the Downtown Rising Initiative to bring long-term health and prosperity to Utah's capital city. 111 has indeed risen as a skyline marvel, showcasing world-class design, a triumph in team unity, and the strength of local craftsmanship. 111 is a contribution to the city that reflects Utah pride and will be appreciated by the downtown community for generations to come.